Right now, every password you've ever used, every bank transaction you've ever made, and even top-secret government files, all of it could one day be cracked open by quantum computers. But what if I told you there's a way to create a code so secure, not even the most powerful computer in the universe could break it? A code protected not by math, but by the very laws of physics. Welcome to the mind-bending world of quantum cryptography, the science of unbreakable security. Welcome back to the channel, where we dive deep into the mysteries of quantum physics and its impact on our world. Today, we're exploring something that sounds like it belongs in a sci-fi thriller, but is very real: quantum cryptography. Imagine a world where secret codes can't be hacked, where spies, hackers, and even future supercomputers are powerless against the laws of physics. That's the promise of quantum cryptography. And in the next few minutes, we'll unravel how it works, why it matters, and how it might transform the way we communicate securely forever. Before we get too deep into this topic, be sure to like this video and subscribe to the channel. This helps to bring more valuable content to the platform for your knowledge and understanding. Remember, knowledge is power. Now back to the episode. Right now, almost all of our digital security, whether it's your bank account, medical data, or even military communications, relies on mathematics. Encryption algorithms like RSA and AES depend on the fact that some math problems, like factoring huge numbers, are practically impossible for classical computers to solve in a reasonable time. But here's the problem. Quantum computers are coming, and they are not bound by the same limitations. A sufficiently powerful quantum computer could crack today's encryption like a hot knife through butter. That means the entire digital infrastructure of the world is at risk. Governments, corporations, and individuals all face the same question: how do we keep information safe in the quantum age? Instead of fighting fire with fire, using math against quantum computing, scientists turned to the universe itself. Quantum cryptography doesn't rely on mathematical assumptions. It relies on the laws of physics, specifically, the weird and wonderful rules of quantum mechanics. At its core, it's about sending information in such a way that if anyone tries to eavesdrop, you'll know instantly. It's not just harder to hack. It's impossible without being detected. This is where the concept of quantum key distribution, or QKD, comes in. Think of QKD as a method of creating a secret key, a string of random bits that only two people know, even if they're communicating over a public channel. The magic lies in the behavior of photons, the smallest particles of light. Here's the trick. A photon can exist in multiple states, like being polarized vertically, horizontally, or even at 45 degrees. If an eavesdropper tries to measure the photon, they disturb it, changing its state. This disturbance reveals their presence. The most famous protocol is BB84, developed in 1984. In it, Alice sends photons to Bob in random polarization states. Bob measures them with randomly chosen filters. Later, they compare notes on which filters matched. From those, they generate a shared secret key. If an eavesdropper, let's call them Eve, tries to intercept, the error rate skyrockets. Alice and Bob immediately know the line isn't secure. That's not just clever engineering, that's physics acting as a security guard. Unlike classical cryptography, where the risk is always someone might figure out the math, quantum cryptography is different. Because of the no-cloning theorem, a fundamental law of quantum mechanics, you can't perfectly copy an unknown quantum state. No matter how advanced technology gets, even with future AI-powered quantum computers, the rules of the universe forbid it. That's why experts say QKD is future-proof. It's not security based on hard math. It's security based on nature itself. This isn't just theory. Quantum cryptography is already leaving the lab. China launched the Micius satellite, enabling quantum encrypted communication between continents. European projects are building quantum communication networks across cities. Banks are experimenting with quantum key distribution to secure financial transactions. Governments see it as a critical tool for national security. And perhaps most exciting, researchers are working on the quantum internet, a global network where information travels with unbreakable encryption at its core. Of course, nothing comes easy. QKD requires delicate equipment, single photon detectors, ultra-stable lasers, and specialized fiber optics. Distance is also a challenge. Photons get lost over long cables. Satellites help, but building a large-scale quantum network is a monumental task. Still, progress is rapid. What looked impossible 2 decades ago is now being demonstrated around the world. So, what's the big picture? We're entering an era where the greatest threats to our security come not from spies in trench coats, but from quantum computers in labs. Yet the same quantum physics that makes those computers powerful also gives us the ultimate shield. Quantum cryptography isn't just a new technology, it's a new philosophy of security. One that doesn't ask us to hope our codes are unbreakable, but guarantees it through the laws of the universe. The future of secure communication is being written in particles of light, one photon at a time. If you found this video as fascinating as I did, make sure to hit that like button, subscribe for more explorations into the quantum world, and share this with someone who loves the future of science and technology. Because the future of security, it's quantum.